Okay, well, thanks everybody for coming. Nice full house. Hope you've had a good Friday morning. Sorry there was no epic 3-hour keynote for you this morning, but hopefully we can get started and have a good deep dive into Git and also look at the Team Foundation Server integration with Git. My name is Martin Woodward, Martin Woo at Microsoft.com, or Martin Whoa, depends if you're in San Francisco or not, I guess. If you want to email me or ask me any questions, that's how you get hold of me. If you want to send me some abuse on Twitter right now, that's fine. I'll read it when I'm off stage, at Martin Woodward. And then some of the stuff I'll be showing you today posted to my blog and stuff. So that's woodwardweb.com. And then, hey, let's find out. Anybody here listen to the Radio TFS podcast? Hey, look at this. We've got some. That's like half the audience. So that's brilliant. That was for the people on video, all right? So, yeah, great. Radio TFS. If all this exciting stuff is really nerdy and you love it, all this TFS talk, then you haven't heard nothing yet. An hour every couple of weeks that's even worse than this. So go to radiotfs.com. My co-host is actually around and about, Greg Duncan. I don't know if he's here. No, he's not. He's bored of listening to me. So, yeah, there's the podcast. I've written a couple of books. Not that that's, makes me an expert. Just means I happen to know clever people like Ed Thompson here, who is a good friend of mine. We've worked together for 10 years?
10 years, yeah.
Yeah, correct. When I knew Ed, he was my height. You know what I mean?
I had as much hair.
Yeah. So Ed and I worked on a couple of books. Ed did the Git chapter in the Pro TFS 2013 book as well, if anybody's interested. So go grab that. It's not quite out yet. The Pro ALM book's actually in stores now, all good bookstores. Well, whatever. There are other good books as well. So, Ed.
Thanks, Martin. Yeah, my name is Edward Thompson. I'm a senior software development engineer on the TFS version control team here at Microsoft. So I work on the actual Git support, the deep down nitty-gritty Git repository management that's in Team Foundation Server and in Visual Studio. I work on a project called libgit2 and libgit2 Sharp primarily. These are the open source projects that actually facilitate our Git repository management. And I'm actually a programmer. I know that you see a lot of PMs at Build, but I'm actually a programmer, not a program manager. I don't really know what they do, so I'll let Martin actually talk about that.
So I am a program manager. I don't really code anymore. I think you probably deleted all the code I did do.
Absolutely.
Yeah, and I don't really manage any people either. I kind of manage I kind of just delete email, if I'm honest. It's probably what I do. I've got manager in my title, so thank you. I stole that joke from Scott Hanselman, actually, so you can give him a clap for that one. I also look after the Coplex site. I do a lot of the open source stuff inside Microsoft. So yeah, it's been pretty exciting times lately. So it's good stuff. It's a great time to work at the company. We're a fairly distributed team. As you may have noticed, I talk a bit funny. Apologies. It's good in America because it makes me sound clever because I've got an English accent. I'm either clever or James Bond, and I'm too short to be James Bond, so I must be really clever. Back home, I sound like an idiot. I live in a field in the middle of nowhere, just outside Belfast in rural Northern Ireland. I'm there on my own. Welcome. I am Team Foundation Europe. So I sit there, just doing my stuff, hacking away, deleting email. And then Ed is a local boy, actually, just based up the road, a short train ride away.
A short train ride away.
Takes about an hour, I guess.
Yeah.
So he's in Berkeley. But that's, not where Ed works remote as well, just on your own in your house, sort of thing, with your dog. The team, so the 50% of the TFS Visual Studio Online team, they're actually based in North Carolina. I nearly forgot where they were. I nearly said Northern California. There we go. They're based, all these states are the same to me, whatever. So they're based in North Carolina. That's where kind of the version control team are. And there is one version control team in Microsoft that does, TFVC and Git, and officially we look after SourceSafe apparently, but not for much longer. There's like 3 weeks left on the support for SourceSafe, so woohoo! Probably shouldn't say that if you're still using it. Never mind.
Right.
Okay. so they do all the source control stuff there, the build team's there, and some of the core framework team. And then the other 50% of the team, they're based in Redmond, in Seattle, Washington. And so we're a distributed team. We've got people spread all over. Our Team Foundation server that we use to build Team Foundation server, it used to live in building 42 in the Redmond campus until very recently. Now we're in the cloud. Oh, it's very exciting living in the cloud. The cloud sounds like this glamorous thing until you've gone to visit it. The cloud is actually a car park just outside Chicago with a bunch of shipping containers in it. And that's where our Team Foundation server lives. That's where Visual Studio Online lives. So that's what we do. Very, very distributed team. And we have people over in India, people in Australia, spread all around the world. Who here is using Team Foundation Server or Visual Studio Online already? Okay, cool. Wow. You've seen this slide already then. And it obviously isn't my slide because the build was good. This is TFS. It's collaboration stuff. It's all tightly integrated. So, you've got work items integrated with builds, integrated with test case management, integrated with source control. We're going to spend, from now on, talking about source control. There are 3 types of source control in the world. Not just, 3 types offered by Microsoft, which there are now, but there are 3 types of doing source control in the world. It's like the check-in, check-out model, like the source-safe model, I guess, or, which is in TFVC is called a server workspace. There's the edit-merge model, like Subversion CVS kind of model. In Team Foundation Server, that's called a TFVC local workspace. And then there's distributed version control, and that's called Git when it comes to TFS or Visual Studio. We didn't go build our own, the TFVC Git for Microsoft 2.0. We work with the Git community, and we actually just use Git. And it's just Git, but Git's fully integrated into Team Foundation Server. Now, Git's different. Distributed version control is a very different workflow, and we're going to spend most of today just really explaining why it's different and how it's different. And you're all developers, so rather than giving you the conclusions, this is what you want to do because it's different, we're going to show you why it's different and how it's different, and allow you to really build your own conclusions as to how you should use Git in your organization and how you should, what Git's good for you, when it might be appropriate and when it might not be. But at the high level, a server workspace is good for large, monolithic code bases that are all tightly bound, and it's very good for monitoring usage of those source files, because every time you want to do something with the server, you have to communicate with the server. If you want to check out a file, if you want to edit a file, whatever, you have to talk to the server. And a local workspace is a good way of doing centralized version control, so checking into the server in the cloud or the central server. But it allows you to work offline easily and allows you to edit files outside of Visual Studio or Eclipse easily. If you just want to go into Notepad and hack a file, it just works. If you do things like delete a file and then do get latest, it doesn't do what a server workspace does and says, you've already got latest. And no, I haven't. Because with a server workspace, you have to tell the TFS when you've done anything, like delete a file locally. With a local workspace, if you delete a file locally and then say get latest, it examines your file system, examines the server, and says, you need a new file. I'll download it for you. So local workspace is friction-free. And then distributed version control. The way I like to explain distributed version control is it's version control, but the history is portable. So when you connect to the repository, you have to do anything with the repository, you have to download the entire repository to your local file system. Every single file, all versions, all history comes down to your local machine. That might sound crazy to somebody who's using centralized version control. It's actually really, compressed. And then, so it's portable history. Now, while I've got my name manager in my title, I used to be a developer, and I'm not marketing, so I'm not really a very good salesperson. One of the good things for you guys about Git is it's actually vendor agnostic. Because this history is portable, if you want to take history from one server of Git and push it to another person who provides Git servers, you can just do that. Git gives you the end of vendor locking when it comes to version control, because that history goes with you. So that's huge in terms of, not locking you into one different provider's tool sets and things. So that's one of the reasons I quite like it. It's also got a really simple branching model. Merging is still painful, obviously, because merging is always painful, but branching is very simple, and we'll show you that. Now, Git is fully integrated into Team Foundation Server and Visual Studio. What do I mean by fully integrated? Well, when you are doing your projects, you have to specify for a particular team project, do I want it to be a TFVC-based project or a Git-based project? Just like in TFS 2012, you had to pick, is this a Scrum project or an Agile project? The type of version control workflow you pick fundamentally affects the workflows you use in your team. So you have to actually pick that when you create the project. If you pick a TFVC project, you talk to that using Team Explorer in Visual Studio. And that goes through a source control provider, which then uses our proprietary .NET API, which you can use. It's an open API, open interface for you to use, but it's our proprietary code, talks to TF version control, and that's how it works inside Visual Studio. Now, we have integrations for Eclipse, and we have integrations for the command line and for the cross-platform command line to talk to DFVC, but it's all based on this proprietary protocol. And then over on the Git side, you still use Team Explorer, but we have a Git provider. Now, anyone who's had to switch source control providers inside Visual Studio has probably got the scars. Yeah, there we go. Yeah. It's not usually a pleasant experience. So we actually magically do that behind the scenes. If you go from a TFVC project to a Git project, we just swap those around for you and do all the magic. It's not painful at all. You can just flip between the two. And we talk to Git using an API called libgit2sharp and libgit2. Now, you might think that's actually quite a cool name. Surely that can't belong to Microsoft, and you're right. It's a fully open source library that Ed's a committer on. He's actually an active committer. I'm also a committer on it, but I think that's more of an honorary thing, really. And because at one point we had to go through, when we ship a product inside Microsoft, we have to scan it for things like swear words and stuff. Turns out libgit2 has a bunch of Linus Torvalds code in it, The days have changed. Microsoft shipping products that were written by Linus Torvalds. What's going on? Anyway, he can be a bit sweary in some of his comments.
From time to time.
Yeah, so I was the guy that had to go through and remove all those swear words and check that in. So if you can find that commit, it is quite amusing, especially the comment thread when people were discussing it. So that's about all I've done, really. Now, and delete email. Now, because it's just Git, it's the standard API for talking to Git within a long-running process. You can talk to a local repository just fine, and you can talk to any other remote Git repository just fine as well. So if you've got a repository from GitHub, if you've got one from Coplex, if you've got one from Bitbucket, you can still just use Visual Studio to talk to that Git repository, and it all just works. It's just Git. Equally, it's just Git on the server. The protocol is the standard Git protocol. So if you want to use Xcode, if you want to use Eclipse, if you want to use IntelliJ, if you want to use Android Developer Studio to talk to Team Foundation Server using Git, it just works. It's just Git. Hooray. Right then. And if you want to move code between the two, you use Git TF. If you want to use Xcode, you can just use Xcode. If you want to go to the command line on Unix, Linux support for Git turns out to be really good because Git was written for the Linux kernel. So if you want to go to Linux and use Git with Team Foundation Server, you can. It's just Git, but occasionally we'll like stick some ASCII art in there just so you know you're using the Microsoft Git. But yeah, it really does do that. And that was the other thing I did, wasn't it? That was about my other contribution, yeah. I got them to change it. You notice it's all made up of T, F, and S. That took me ages to do. Okay, there we go. All right, thank you. Right, that's my sole contribution to this entire demo. Okay, let's go over, and we're actually going to demo just very, very quickly Team Foundation Server and Visual Studio in Git. And this is kind of, normally when you go to a Git demo, this is the entire 75 minutes. We're about to condense now into the first, we did it in the first 15 we're about to do. So I'm talking to a Team Foundation version control project here in Team Explorer. I click on the little plug thing to connect to a different project, and I'm going to go over and I'm going to connect to my Git repository in Fabricam Apps. And you see, it just connects and it switches you over into Git. But it's still just Team Explorer. It's still just Visual Studio. So if you're used to using that interface, it's all very familiar. The first thing you need to do is clone the repository. Take a copy of that repository and bring it locally to your disk. So we're going to come in, hit clone repository, and we're going to bring it down and clone it onto our disk. So this is going up, talking to the cloud, and downloading all that code from Visual Studio Online, putting it locally on my local machine. So there we go. It's cloned successfully. Now, one of the neat features, this is Visual Studio 2013. Who's using 2013 here? OK. It's Visual Studio 2013. It's just like Visual Studio 2012, but with color, is how I like to describe it. So I come in here. If I click on Hello World, I can open it up. It actually shows you your solutions that are in the Git repository, and I can just go in and quickly make a change. And this is obviously a program the PM wrote, because, you know, it's very, very simple. So I can just come in here and I can make a comment. Notice a couple of things. If anyone's been using the current Git integration, this is kind of a future version, which is what's in Update 2 RC, just slightly before, but combined with a version of, we've added Git code lens support. That's not coming out in Update 2. That's going to come out in a future update. But we just wanted to show you what this is going to look like, just so you know it works and things. And you can see here, I can actually go through. I can tell there's one reference to that class. I can tell it was last edited by Ed. I can come in here and see this method was added by Ed and 4 other people. And I can scroll down and look through the history. It's pretty cool. So there we go. And I can just come in and edit line here, make a change, Control Save. And it's just version control. So if all you want to do is just standard version control stuff inside of Visual Studio, it's just the same thing you've been doing all along. Fix a comment. There we go. I can associate that with a work item just to save time. I'm going to do it with a work item ID I already know. So there we go. And then, so as I push my commit to the server, it links work items with commits, just like you would expect from Team Foundation Server. And I can hit commit. Commit would just commit it locally. If I do commit and sync, what that actually does is commit it locally, so you've got a local copy. It then pulls down the latest changes from the server, merges them with your local copy, and then assuming everything's good, no merge conflicts, it then pushes those changes back to the server. So that's the closest operation to a check-in TFS is commit and sync. So that's done it all in one go. And then let's go into the server, pull the branch down, merge, and push it back up again with the results. It doesn't need to merge anything because I've just cloned it. OK, super. Right then, so let's go back to deck. A couple of things. We're going to spend the rest of the time in the command line now. Ooh, hardcore. Ed will be doing a lot of that, thankfully. A few top tips for you. If you want to scan that QR code or download the deck, there's a link to a blog post I did. First of all, you need to install Git for Windows. That's the open source command line for Git. It's based on Core Git. That's OK to begin with. Then what you want to do, who uses PowerShell here? OK. If you don't use PowerShell, you should use PowerShell, because when you type ls, it doesn't shout at you, is why I like it. So go over, install PoshGit, which is a PowerShell plugin for Git. And we're going to be using that today as well. And that does things like decorate your prompt. It does lots of cool auto-completes for you. It's really good. A guy called Keith Dalby, who's an MVP, wrote that. And then you want to install the Windows Credential Helper from a guy called Andrew Nurse. It's a Coplex project. And that actually stores, when you're using your credentials from the command line, you have to type them in every time. This actually stores them in Windows Credential Manager, so the secure credential storage on Windows, which is what you want. That's where, when you do save password in IE or save password in, that's where it stores them. So you use that, and then it'll store your passwords, and you don't need to keep typing them in every time. So install those 3 things, and then you're good to go. When you're installing Git for Windows, top tip, if anyone's watched The Fish Called Wanda, you know what you should do is pick the middle option. The same is true when you're installing Git for Windows. Pick the middle one. When you're asked where you want to install it. So by default, it says use Git bash only, which is like a Cygwin type bash interface. That can be hard to use if you're used to the command shell or PowerShell. If you add Git to the path, it makes it a lot easier. And remember, friends don't let friends use Git bash, okay? All right, Ed.
Thanks, Martin. So a difference between Git and Team Foundation version control is the way it stores its history. And this is very important. We talked about how Git repositories, you get a full copy of the repository. You get a full copy of history every time you clone it. And in Team Foundation version control, that's not the case. All of the history lives on the server. You're just making changes locally, checking them in up to the server. Okay? To enable this sort of difference, to allow us to take history with us, we've actually got to model the repository a little bit differently. We talked about how cloning pulls down an entire copy of the repository onto our local machine. So in this example, I've got a copy of the repository, and so does Bob on his local machine. Now we both make a change, and we check in locally. I'm going to check in commit number 4. Bob's going to check in commit number 5. And at this point, these are just local. In Team Foundation version control, when you check into the server, you modify, you update the repository, and you publish it for others to get. As soon as it gets checked in, other people can start downloading that change. That's not true in Git. Your commits are local, and the publishing step is actually separate. So in this case, I can get this change from Bob. He can put it up on the server, push it up to the server, and I can bring it into my repository. When I do that, I'm not actually bringing it into the working directory. I'm only modifying the history of my repository right now. I actually need to, if I want to bring his changes in and combine them with mine, I need to merge them. Okay? When I do that, I'll take both of our changes and I'll get a whole new commit. So what you can see here is that history is kind of diverging and merging back together, and this is a core feature of Git, and it's what enables this distributed version control to really work. This is actually modeled not in a linear fashion, like what you'll see in TFVC, where you've got change set 1, change set 2, change set 3. It's actually modeled as a graph, and this is if you took graph theory and didn't fail it like I did, you'll know that this is a directed acyclic graph, and if you failed it like I did, you'll just know that that means that change set 3 leads to change set 4, and change set 4 can never lead to change set 3, which makes sense. We don't have a time machine to go back in time and start basing our commits off the future. Okay? This sort of graphical nature of the repository, though, can get a little hard to look at, a little bit hard to wrap your mind around when you want to start looking at it. So as a result, in Visual Studio, what we do is we provide you a little bit simpler interface. We flatten the repository output. We just kind of show it in reverse chronological order. It's a little bit of a lie, but it's an easy lie to swallow, because you really just want to see the changes as they float in chronologically for the most part. This actually matches what you'll see in the command line. If you run the git log command from the command line, that'll show you the history there. And just like you'll see in Visual Studio, you'll just see the changes one after another by default. You can, if you really want, you can look at the graph. From the command line, you can specify the -- graph option to git log, and it'll show you the log. This can start getting really crazy. You can start getting multiple parallel lines of development as all of your developers are making branches and modifying files independently of each other and eventually merging them back together. This graph can start to take up a lot of space, but you can see it. It can be very helpful to visualize. We don't have this in Visual Studio yet. We're working on it right now. It's very pretty. There's lots of nice vector graphics because a PM decided that it shouldn't look quite like the command line. But until then, we're going to have to look at the flattened version. You'll see that in a future update to Visual Studio. The other lie that I've told you so far is about the commit IDs themselves. I said that when I made a change based on commit number 3, I would get commit number 4. And Bob, meanwhile, he's making a change on commit number 3. He gets commit number 5. Yeah. So how did we know which one of us got 4 and which one of us got 5? The idea behind a distributed version control system is that there's no server to arbitrate who gets what ID. We don't even necessarily have network connections. We could be hacking on a plane and committing while we're in the air. So we don't actually get these monotonically increasing version numbers like you get in TFVC. Instead, we need something a little bit more advanced. In Git, what we do is we actually take the contents of the commit and we hash them with SHA-1. It's a nice, strong hash. And we take the output. It'll be a 20-byte hash. We turn that into a 40-byte ASCII armored hexadecimal string. So your commit IDs are 40 bytes of hex long in Git. We really don't need to, since SHA-1 hash does a good job of kind of randomizing throughout the space, we really don't need to talk about all 40 bytes. We usually end up talking about the first 6, maybe 7 characters, but we do end up talking about commit IDs like 42D460A. You get used to it pretty quickly. In TFVC, you'll very quickly start ending up with 4-digit or 5-digit change set numbers. So it's not that much of a stretch to switch over to these hexadecimal strings, but it is something to be aware of, and it is a bit of a change. Okay. I said that we take the contents of the commit and hash them. When I say that, what I mean is we actually drive in to the commit itself. So what is a commit? First of all, it contains the metadata about these changes. Who made the change and when is certainly an important characteristic. The commit message itself, the comments, as well as the parents. This is actually how we build that graph in Git. We crack open the first commit, and we find out who its parents are, and we can just keep walking backwards. And that's how we build that graph. In addition to all that metadata is the contents of the repository itself. And this isn't storing a delta between the two changes. It's actually the whole repository. So in this commit that I'm showing right now, I'm adding this file, file1.txt. If I make another commit and I don't touch that file, I just create another new file alongside of it, you'll see file1.txt and file2.txt because it is storing the whole repository. And just like we hash the contents of a commit, we hash the contents of the files that go into it. So they're called blobs in Git. We hash the blob and get an ID for it, and then we build a tree. That's how we build the hierarchy of our repository itself. And we'll hash that. Then we'll store that in the commit. Since we actually compute hashes for all of these items, our history is actually immutable. We talk sometimes about rewriting history in Git, but we don't really rewrite it. We can't remove these commits. We can't change these commits because their contents themselves led to their IDs. If I were to try to go change the comments on one of my commits, that would change the hash that we computed, and then that would change the ID. So instead, what we actually do is, let's say we want to make a change to our history. We don't rewrite it necessarily, but we can update it. I can do something like amend my commit. Let's say I made a typo in my commit message and I do want to go update it. What I'll actually do is create a new commit that has all the contents of the old one, as well as my new message, and I'll have both of them, both of the commits in the database, and I'll just throw the other one away when I don't want it anymore. So I actually do have a full new commit that replaces the old one. The thing to be aware of is that that's pretty dangerous when I've shared that commit. If I've pushed that up to the server, then somebody could have downloaded it, and they could be making changes based on it. So they've got that commit now in their history, and they've made subsequent changes that have that as a parent. So if I were to go try to remove that, then that would just screw up their history, right? They're now depending on a commit that I've tried to get rid of. So in order to, if you want to try to do this to a published commit, you can do it. You've got to specify the force flag when you try to update it. And when you try to do a force push, the server will actually stop you by default, unless you're an administrator. Administrators can do this. But we do restrict this access in Team Foundation Server. You can do it on a per repository or a per branch level.
And that's the feature of Team Foundation Server that restricts that force push.
That's correct.
Okay. Yep.
That's correct. So, yep.
How would that behave if you were using, for instance, Git extensions or another Git client?
So the question was, what's the behavior for using Git extensions or another Git client?
Mm-hmm. And it's exactly the same. If you're using another Git client, say the command line, If you try to push and rewrite history, it'll immediately reject you and tell you need to specify the force flag, because this is so dangerous that even a Unix command, you need to specify extra options in order to start making changes like this. But if you do specify the force flag, then it will check on the server level whether you have the required permissions to do it or not. It doesn't matter whether you're using Visual Studio or whether you're using Git itself. Okay? The question was about server hooks. Let's actually talk about that after if you don't mind. So let's take a look at what this actually looks like from inside the repository. And right here, I'm in my working directory for a little Git repository. If I just look around, I can see the files that are contained in it. And I also see this directory called .git. If I go into there, that's actually my repository itself. We mentioned that I have a full copy of the repository locally, and this is actually where it's stored. This is a very, very simple little repository storage mechanism for Git. And one of the things in here is the objects directory. And these are the atomic units that we were talking about. These are my commits, my trees, my blobs. And if I look in here, I see that I've just got these 2 characters of hexadecimal, and these are the first 2 characters of all my IDs, of the 40 character IDs. And if I go in a little bit further, I can see that that's the full ID. If I want to look at the file itself, I'm going to use a Git command called catfile. That'll just unzip it. Basically, these are all stored compressed. And I can look at actually the contents of the commit itself. This is basically just a zipped text file. And again, it has all that metadata. It's got the author information, the timestamp that it was committed. It's got the parent, so it can build the graph. This one's actually got 2. And it points to a tree that contains all of the changes. Okay? And those are the files that are contained in the commit. Okay? So if you start looking at this, you notice that it's a text file, and you start wondering, well, maybe I could actually manipulate it just like it was a text file and actually influence the Git history. And to an extent that's actually true. I can come over to Visual Studio, and this is pointing to the same repository. And if I pop back to my working directory, I'm going to add a file.
Being a developer, of course, Ed's using Vim here, because he's hardcore.
Yeah, sorry. I'm an old Unix guy. I like the VI editor. And I also think that I should get a raise.
Yeah.
But it's not very important. Nobody takes me seriously when I tell them that. My manager doesn't really listen. But if I pop back to Visual Studio, look at these changes. I've got this new file. I'm going to add it to the changes that I'm about to commit. But again, I'm not as convincing here. If I go into my Git settings, maybe I don't want to be me anymore. Maybe I want to be somebody else who actually has a little bit more power. Okay, we're going to go ahead and save that setting. Pop back to my changes. And I'm going to click commit. If I go to actions, I can look at my history, and we'll notice that, hey, Bill Gates absolutely thinks I deserve a raise, which I'm very flattered by. And I'm absolutely going to share that with the world. So if I pop back to my Git repository, go to my changes, just like Martin pushed that earlier, I'm going to find my unsynced commits and push it up to the server. Okay? Once it gets there, I'd like to think that whoever sees it is going to take note of it and then...
Yeah, well, we'll see. That looks a little bit alarming. First of all, I'm alarmed. I'm hoping Bill Gates doesn't have alerts set up on TFS is the first thing. But the second thing I'm alarmed about is what's going on there. It says in history, if we look in history, it looks like Bill Gates did it. So that Git can only store the history of the author and the committer, and which is based in a text file. But we can actually, over at Team Foundation Server, when you push those changes, you had to authenticate to TFS to push them. So because we capture that authentication point. If I look in history over here on the server, I can see there's that commit from Bill Gates saying Ed totally deserves a raise. But if I actually go look at that commit, I can tell that TFS has audited that it was pushed by Ed Thompson. So when I see some suspicious code arrive like that, I say, Ed, what gives? Now, being an administrator, I could also rewrite history and then force push and get rid of that, but there we go. So TFS gives you all the auditing capabilities you need for an enterprise-friendly use of Git. Great, so let's talk a little bit now. Oh no, let's just show you some of those settings first of all, actually. So Ed was in there showing you the Git settings. If you wanted to, you could do all this from the command line, git config, blah, blah, blah. You see the checkbox, enable download of author images? That means use Gravatar is the short version. But you couldn't get past legal because it's got a trademark in. So enable download of author images. So when you're in history, Gravatar profile images. And then you've got a couple of settings there for ignore and attributes. If you've created a Git repository locally, one of the cool things you can do from Git settings is just go in and add a default git ignore file. Git ignore is a file that specifies, hey, these are the files that might be in my working directory that I don't ever want to commit into history. DLLs, object files, things that get generated as part of the build, all those random SUO files and random things that Visual Studio sometimes generates. You don't want to check any of those in. And so we actually worked with the open source community, generated a default git ignore file that's like a good one, a best practice git ignore, contributed that to the open source community, and then we include it in Visual Studio as well as a default for you. And the same is true with Git attributes. We store a file which shows you, again, it's another config file, which tells Git which files should be treated as binaries, how you should merge those files, things like that. And it also specifies line ending conversions that you might want to use for different file types. Git, unlike TFVC, has line ending conversion built into it. So if you're sharing files with people on Unix, for example, you have the whole problem where Notepad can't open Unix-style line endings, but that's what all the guys use over on Linux. So the option that we recommend is that you set auto COLF equals true. And if you don't do anything, that's kind of the option you end up with. You might think as a Windows developer, why do I need that? And that's because if you're taking an open source repository that was done by a guy on the Mac, and then some JavaScript library or whatever, when you check it out on your local machine, it'd be really good to have those line endings automatically converted for you into Windows-style format, which it does. But even cleverer, when you go and you do a new commit into that repository, before it creates the commit ID, before it generates that hash, it actually turns those line endings back into Unix-style line endings, and that's what it hashes, and that's what it stores in the repository. So it keeps it in a unified format, and you're going to have the most success using different third-party Git tools, like Portable Git and things like that, if you have auto COLF equals true. Ed mentioned as well that the commits store a snapshot in time of all of the files in the entire tree at that point in time. And it doesn't store deltas. So how on earth does it handle rename? Rename is a delta operation. The trick is it doesn't. Huh? That's crazy talk. What it does, because everything with Git is done locally, it just stores that in the repository as an add and a delete. And then because all that data is local, and you've got a really fast CPU locally, hopefully, and not even that fast, to be honest. My phone can do it just fine as well. It actually does a comparison of, if you've got adds and deletes, it does a comparison of the file contents and works out if it was a rename or not. So as far as a user, you see it looks like it tracks renames, but it doesn't really. How that actually works is it guesses, it breaks down the file into chunks, and it computes a hash for each chunk. And if like 75% or something, is it?
60% by default.
There you go. Okay, if 60% of the file is the same, then it figures it's a rename. And that allows you to actually do a file and change the name of it when you're renaming it because you've refactored it, or maybe you've moved the folder and the namespace changed or whatever. It just all works. And me and Ed have been doing version control for 10 years now, and with lots of different version control systems. This horrifies us at first. This is not how we ever did it, ever before. And you've got to remember the people who wrote Git had never written a version control system before, so they didn't bring any of the previous ways of doing things with them. They did things, and you know what? It turns out it works better than tracking renames, because users lie, as we found. Quite often, somebody will take some files, they'll, oh, I need them to be somewhere. They'll move them over to a different, move them out of the repository somewhere. The system sees that as a delete from your repository, and so it tracks it, it's a delete. And then they'll come and, oh, actually, no, I needed it in this folder. I needed to move it. So they'll add them back in again. So it sees them as a delete and an add anyway. And so it recorded them as a delete and an add. And by doing it heuristically, it's actually a more accurate measure of what's a rename and what's not. So while it was slightly scary at first, it actually works really well. And understanding that helps you understand the core design paradigm in Git is that it takes guesses, it uses heuristics. It's more of a Bayesian version control than a binary version control, if you know what I mean. It's really helps you understand the kind of the fundamental nature of Git. Let's talk about branches. In branching, when you have a Git repository, when you have a TFVC repository, branches are in path space, which means they're in a folder. When you go into Git, branches are actually across the whole file, across the whole repository, sorry, okay? So you don't have them in the namespace. The branch is actually across the whole repository. So, Ed, do you want to explain how that works?
Absolutely.
Quickly?
Yeah, so if we go back to our illustration of the graph, our illustration of history, we've got the same one we had before, where Bob's change is down at the bottom, and our change is up at the top, and it's been merged in. But now we've added a couple of decorations, right? Instead of Bob's change just being Bob's change, we've actually put it in a branch called Bob's. And mine, we've put in a branch called, well, mine, because I'm not very original, because I'm a developer and not a program manager. But Bob's change is just a pointer. We've just got this simple pointer to a commit. That's all a branch is in Git. It's a pointer to a commit. Mine is a pointer to that. And then we've also got this special pointer called head. Instead of pointing to a commit, head points to a branch. And that's how we know what branch we're on. So when we make a new commit in this graph, what happens is the pointer to head stays the same. We're still on the mine branch. It's just that we update the pointer to mine to point to that new commit that we just created. Okay? If we want to take a look at how that works in Visual Studio, I've got this same repository open that Martin was using before. And if I go and look at the code, I notice that it doesn't really, well, there's kind of a mismatch of white space, and actually, it doesn't even compile. There's an extra brace
I am a
in
program
there.
manager after all.
Yeah, so I'm going to fix this up for him. Okay, I'm going to do that. I'm going to do that. Ooh, you know what I want to do? I actually want to do this in my own branch, I just realized. And I can actually do that while I'm making changes in Git. It's very flexible. I can pop down this little tab, create a new branch, and call it Fix Martin's Poor Taste, because PMs don't know how to write code, it turns out. And I'm going to go ahead and save all that data, and I've actually made that change right there in this branch. Okay? And since it's a pointer, it's very easy for me to switch back and forth. And as I'm doing that, oh, I'm sorry, I saved it before I did that. Let's actually make another change here, because that still doesn't quite fit with our white space guidelines. Okay? And I'm going to save that on the master branch. So as I flip back and forth between the branches,
Committed.
oh, I'm sorry. You know what I didn't do? I didn't commit it. Of course, I was just making the changes locally. So if I go ahead and commit it, great. It's going to tell me about the new commit I just made. If I pop back to my branches tab, now I can actually do the flip back and forth between these branches. And you'll see that it just updates right in my editor as I make these changes. It's very, very lightweight. So all it's doing is updating that pointer and checking out the changes between the two versions. If I actually want to dig in to the repository itself, we can, just like we dove into the Git repository earlier, we can go into the Git directory and look at the changes. So a branch in Git is called a head ref, which is just Git speak for a branch. Pardon me. And if I look at look inside that directory. I've got these two files. These represent the same branches I've got in Visual Studio. Can look at that one. This is the master branch, and I can look at the other branch. And these just have the 40-character commit IDs. I don't really need to worry about that. I can just worry about the branch names, just showing you how this works internally. And I've got another file called head here at the top level of the repository. And again, if we open that up, it just points to the branch that I'm currently on. We've got the same integration in Visual Studio. So as I make changes in my Git repository itself, I can check out a new branch. It's going to update that, and when I pop back into Visual Studio, it's going to tell me that the file's changed. But if you look here in the Branches tab, I notice that I have actually changed to the master branch.
Cool. Yep.
What's the mspersist.xml file?
So that's
The
actually,
question was?
yeah, the question was, there's a special file called mspersist.xml. If you're a Git user and you've cracked open the Git repository already, you'll know that that's not a normal file. That's how we store the included and excluded changes list. And if you want to talk about that afterwards, we can.
Okay. So let's talk. So branches exist at the repository level, and they're exceptionally lightweight. Very easy to create branches, as you just saw. Merging's still a pain, though, because merging is always a pain. The further you diverge in two code bases, the harder it's going to be to merge. You might end up with merge conflicts. What happens when you do a merge? If Bob does a change while I made a change, I need to then create a new commit, which results with my change and Bob's change in the new commit, and then head moves on. Now, that's a standard merge. Git has this great thing called a fast-forward merge, and that was really confusing to me when I started using Git. What does that mean, fast-forward merge? It turns out it's really easy. If you were over on your feature branch and made a change, and then you want to merge it into master, and you haven't changed anything in master, well, Git's smart enough to say, hey, I don't need to do anything. So it doesn't create a commit for you. Because these are just pointers, it just moves that pointer up and goes, OK, so now you've got the same commit ID in both the feature branch and the master branch. And that allows you to very easily see what's different between those branches. Let's just quickly show you merging inside of Visual Studio. It's super easy. So Ed's got these changes here. Now, I wasn't really paying attention. I don't speak to Ed very often because he lives miles away and we're on different time zones. So I'm going to come in here and I'm going to make some changes. Maybe I'm on my master branch. I'm going to get rid of that file. I'm going to come in and I want to internationalize because it's about time I sold my Christian Binders here. So it's about time I sold my program into Germany. So I'm going to come in and I'm going to impress you with my fantastic German. So I'm going to go, Hallo Welt. There we go, because I've been told I have to internationalize, and surely that's how you do it. Just change all the string literals. Is that good?
It's that easy, yeah.
OK, we'll do a code review of that later.
Yeah,
and
great.
then I'm going to do that. I'm going to commit that into my branch. And I'm going to come in here. Sorry, just go up to there. I'm going to go into changes. I'm going to say make it German. Perfect. Or alles klar. There you go.
Ah, very good.
And then that's committed. And then I'm going to do that. Now, if I try to pull from the history after Ed had pushed, I might want to now merge my changes in. I might notice that Ed had done some work. So I'm going to actually merge my change with the change that Ed did over on Fix Martin's Poor Taste, which is here. And we can see, I want to see there's Ed's change, there's my change. OK, right then. So I'm going to go to the branches screen, and I'm just going to say merge. Now, this is actually quite easy. I'm going to say merge from Fix Poor Taste into master, hit merge. And then because now this is a little bug that got fixed in the actual final RC build. So there we go. You see it twice, but it works now. So I'm going to come in here, and I'm going to see there's a merge conflict. Notice it doesn't get in my way. It doesn't give you a modal dialog box. It just tells you there's a merge conflict. And because I'm in Visual Studio, I can use all the cool graphical merge tooling that we built for TFVC. I can use that inside Visual Studio to go, you know what? Ed's actually fixed that annoying compilation problem I was having. I wondered what that squiggly red thing meant. But I can come in here, and I can still, again, come in here, and I can maybe copy-paste from here my fantastic German, and I can go over here and paste it into the merge result because I have to manually go in and actually fix this merge to make it do exactly what I want. Brilliant. And I can hit accept merge, and then I can go commit that into my repository. There we go. So there's one reason to use it. Now, we're going to go spend some time and talk about quickly the Git protocol.
Yeah. So very quickly, we've been talking about how to talk to your local repository. And that's certainly very important, but more important is being able to share your changes. We still need to be able to get our changes up to a server so that everybody can get them, so that we can collaborate. We still want to do continuous integration. We'd still want to do work item tracking and build and test integration. We don't give that up just because we're talking to a local server. And the Git protocol itself is very, very lightweight. Instead of transferring those little, we dove into the Git repository and saw those objects, those object files. Instead of transmitting those to the server, we build a pack file, which is basically the objects themselves, only it's not quite a zip file, but you can think of it that way. And we push those up to the server, we pull those down from the server. So the server is actually tuned to deliver us these pack files, and it's very, very efficient. It's generally only limited by your bandwidth at the client level.
Yeah, if you can saturate Azure bandwidth, then that's very impressive.
Yes,
So, yeah.
exactly so. So similar to the protocol, once we get this data from you in Team Foundation Server, so we do something a little bit differently in TFS. We actually stick this into SQL objects. Okay, raw Git, we saw stores itself all on the file system. Once you hit Team Foundation Server with your repository, it goes into SQL tables. So we store the reference data, we store an audit trail, so who pushed what and when, and we store what's called the ref log, and that shows how branches are changing and who's updating them. Okay? A little bit different is what we do with the object data themselves. Once you've pushed that pack file, we split it apart, and we stick those objects in an on-premises TFS install. We stick them into your SQL server. And that's so that you can take a full snapshot of your SQL server at any point in time. You can back it up logically. We just stick the blobs right into SQL. On Visual Studio Online, we actually put them in Azure Blob storage because we don't have to make it easy to back up. We just have to be able to back it up ourselves. And so it doesn't matter that, that it's in a separate place. We'll deal with it that way. It's actually a little bit cheaper and a little bit faster if we do it in Blob Store rather than going to SQL Azure. So once we've got that data, we actually want to do a little bit of processing on it. It turns out that Git is not particularly wonderful at certain things that we want to show you. Right here, I've got a screenshot from Visual Studio Online. And if you'll notice over on the right-hand column, we see some information about the changes that have gone on in this repository. We see the last person to make a modification to these files, the commit message that affected those files. And if we think back to the log, to the graph that we saw of Git, to be able to figure out what changes affected these files, we've actually got to walk all the way back in time and diff each change set, each commit rather, against the previous one to figure out what changed. And that's very expensive. We don't want to do this every time you hit a web page and navigate around. That would get very, very computationally expensive. You just sit there and see a spinner. That's no good. So what we actually do is we kick off a background job every time you push to analyze this data. And we build indexes. We can build some really rich reporting information about your Git repository every time you do a push. And of course, again, we do it in the background so that you don't notice it. While we're doing that, we also look at the work item linking that you've done. Martin showed you linking to a work item. We do that in the background as well. That way you can push 1,000 commits, and we won't pause while you do that push. Okay?
Great. So you've been playing with Git. You want to start using Git. How do you start using it inside your organization? The thing I always find is getting used to Git. It's just source control. It's just different. It's not better. It's better at doing simplified branching. It's maybe better at doing things offline and having commits. But it's just different, really. And it's very different because of a different model you have to go. To me, it was like when I made the change. I've been around long enough, been mainframe programmer and whatnot. I used to have to do lots of procedural programming and things back when I actually used to code. And when I went from procedural to object-oriented programming, I kind of had to rewire my brain to think differently about how I code. It was the same with Git. When I came to use Git, I had to kind of rewire my brain a bit to think Git. But now I've done it, I can't not think both ways, you know what I mean? It's like learning to drive on the wrong side of the road, or the right side of the road, as you guys call it, but whatever. So yeah, Git's different. Build out, some proof of concepts with a team. Give them the choice of when they move. Don't force it on people. That's the worst way to encourage change in your organization, is to say thou shalt. And build up some internal set of expertise. It's different. You will need to learn some funky command line things, do some funky stuff if you want to mess around with your repository. So build that expertise out gradually with some proof of concepts, and then roll it out slowly with your team. If you want to migrate history, you can use Git TF, which is an open source project Ed and I work on. It's actually written in Java. There you go. And it allows you to take changes and actually migrate them between Git and TFVC. So you can take all your history from TFVC, push it into a Git repository. If you use the Git command line, you can use Git SVN to do the same thing with Subversion. And one top tip is you can just take a snapshot of your latest code and have that as one repository, and you can have multiple repositories in your team project. So you could actually have a separate repository, which was the 15 years of history that we have for the system or whatever, and then you don't need to have your developers downloading all 15 years of history. They can download a fairly recent reorganized version, but it's still there and accessible, and you don't need to keep SourceSafe around or whatever you want to use, It still works. If you're going to move to Git. Don't try and live in some sort of hybrid world where you're using Git locally and then TFVC or Subversion or whatever on the server. It just hurts, and you're going to have this friction. So move to Git. Give them a Git project in TFS, and then allow them to store the code there, so you get the code off their machine and into a server where it can be backed up. And then for large repositories, you might want to consider doing your refactorings first. So you want to get rid of binary dependencies with Git, because with Git, you download the entire repository to your local machine. If you've got 100 versions, if your build system checks in DLLs every single build into your source control repository, you're evil. But also, it's probably not what you want to do with Git, okay? So what you want to do with Git is get rid of these binary dependencies from outside of your source control repository. One might argue that's the best practice anyway. And you can use NuGet to do that. NuGet's your friend there. When if you're trying to get your code from, maybe you work at Microsoft and you've got these big monolithic code bases going back 20 years or whatever, you can take those big code bases, refactor them first into components inside your centralized version control system before you then migrate individual components, component per component over to Git. Don't try and take a monolithic code base and then refactor it, because otherwise you'll just end up with a huge Git repository again that you can't find any code for. Best way to get started. Who here's got a Visual Studio Online account? Okay. Everybody else, go get a Visual Studio Online account. It's free to use. Just go try it. Go use these features. Go have a play. The Git support is built into every single version of Visual Studio, even the Express versions of Visual Studio 2013. If you're using Visual Studio 2012, you can get an extension from the gallery that we wrote, so you can use Git in Visual Studio 2012. Go use it in Visual Studio Online. Who here has MSDN? You also already own Visual Studio Online, so just go use it, okay? The important thing here is it's all about choice. You can use Team Foundation Server, and your teams get to choose which version control workflows for them. We did the Java tooling for TFS. Ed does a lot of stuff on Unix as well and on the Mac and things. I kind of know that world quite well. And you don't have to have this conversation with them trying to convince them to use TFVC, because they fear, TFVC, what's that? Oh, it's Microsoft. Oh, that sounds a bit scary. I don't know. But you can tell them, use Git, and they go, okay. But just give them the URL to push their repository to, and now you can standardize on TFS, and they don't really care. They don't really know. They just get to use all the cool features like the website, like the work item tracking, like the builds, everything else that TFS is integrated with. They can just carry on using the tooling they're using. So it gives you a choice of platforms, gives you a choice of workflows. Okay, please fill out your evals. We've had historically low recordings on evals, so I've been told I have to ask you to fill out your evals. To be honest, we read all the comments. Our managers are the ones that read the scores, but so whatever you want to do with the scores. But the comments is what we read, okay? So if you can leave us some comments, that would be very good. You can take a scan of that. Drop us an email. I have some Visual Studio Hearts Git, iHeart Git, Visual Studio stickers, which I'm going to give out at the back door there if people want some as they hand out. But you have to promise me you're going to do an eval, okay, before I'll give you a sticker. Okay. Thank you very much for your time. It's been a pleasure to see you. And
Thanks, everybody.